Hi class, welcome to our video for our BME 147 class, measuring microfluidic properties. We'll be examining the effects of capillary action and surface tension on the role of retaining water within soil. To conduct today's experiment, we will be using a scale with a measuring cup, a large flavor injector, a funnel, polyester balls, a reservoir bowl, and today we'll be using aquarium substrate. The particle size of these range between 0.5 to 1 millimeters. We're going to also need a shot glass, water, and as well as some weights to provide us with varying results. My name is Max.
This is Kim.
And we're going to start by prepping our experiment. So what you want to do first is to measure out 25 grams of your soil, and you're going to funnel into this flavor injector. Now it's important to note that at the bottom of this flavor injector you will be inserting polyester ball. This is to prevent any experimental errors. You reassemble the syringe and get your shot glass of water. And the key thing to note right here is the reason why we're doing this is to ensure full saturation of the soil, as well as to ensure that all air bubbles are removed. What I'm going to be doing right now is expelling the water 3 times. This should do the trick to removing all air bubbles. It's also important to notice that the water coming out is fairly clear. On our last and third pool of the water, I'm going to actually remove the pump from the syringe. Okay, the water is going to slowly drip out. So we will examine the amount of water that's just retained right now. So what you do is you empty your sample into the reservoir. Try to get as much of the actual soil as out. And we're going to be measuring this onto the scale. So keep in mind we had 25 grams of pure aquarium substrate. And we're gonna do the measurement right now. And we got a reading of around 33 to 34 grams. So it's a definite sign that water is being retained within this soil. So we're gonna continue to repeat our experiments with 3 other weight sizes. So the first one we're gonna do is 1.25 kilograms, followed by 2.5 kilograms. And the last one we will do is at 5 kilograms. So now I will be fully saturating the water. And then we're going to apply our 1.25 kilogram weight. Alright. And then we're going to weigh out how much we're left with. We began with 25. Now we are left with 32 grams. 32 grams. And we're going to begin our next one. So once again, we're going to be starting out with 25 grams. So right now I will be repeating the same steps of saturating the substrate. So this is going to be application of 2.5 kilograms of pressure. Alright, so we began with 2.5 grams and now we're left with 31 grams. And we're going to go ahead and record that information on this chart. The last weight class for this set of soil, 25 grams into the funnel, saturate soil. Okay. And now we are applying 5 kilograms of pressure. We're going to tear the measurement and see how much we're left with. Alright, our results say that we got 30 grams of sand left. Okay class, we're going to go on with our next set. Start off with 25 grams. 3 rounds of flushing. We're going to actually put a 1.5 kilogram weight on top of the pump. And we're going to observe the results of doing so. And let's see what we get. So we're actually left with 28 grams of substrate and water. Third experiment, adding 25 grams. Start with 3 rounds of flushing. There you go. 2.5 kilograms. Pressure has been applied. We are left with 27 grams. We're adding 25 grams to the last of 4 experiments of the second soil type. 3 rounds of full saturation. Applying 5 kilograms of pressure. Measure how much we're left with. 27 grams of substrate that's left with water. Alright class, we have reached a conclusion of our experiment. We're going to be doing a quick review of our results. As you can see, we have two soil types. We have the black sand with a particle size of 0.5 to 1 millimeter. We have the laterite with a particle size of 3 to 5 millimeters. As you can see, there's a trend, and there's a different trend on both of these, and we'll be explaining the phenomenon of each of these.